So you're going to notice that we are getting some things out of order. We are going to do section 4.4 before we do 4.3 because 4.4 focuses on graphing secant and cosecant. These are our reciprocal functions for sine and cosine, and you have already done all the hard work. I promise. This section is going to be so easy. Section 4.3 focuses on tangent and cotangent. And those graphs look different. They're different, they're unique. So we're going to go straight to what we already know and work on those. Secant is my reciprocal of cosine. You know that already. Secant is reciprocal of cosine, which means that secant is undefined when cosine x is 0. So if cosine is 0, secant is undefined. Well, where is cosine 0? Back to your unit circle. Your cosine function is your x coordinate. Cosine is undefined at those odd pi halves. Cosine is undefined, or cosine is 0 at the odd pi halves. Oh my word. Cosine is 0 at the odd pi halves, which means secant is undefined at the odd pi halves. Now that informs this next choice, this next bit of information on our domain. The domain of the secant function is everything but those odd pi half values. So the domain of my secant function is all values of x such that x is not k pi half, where k is an odd integer. So, integer. So, all values of x except our k pi halves, where k is an odd integer. So, those odd pi halves. That's where my function secant is undefined. Range of secant, range of cosine is the middle, -1 to 1. Range of secant and cosecant is the rest of it, the outside, -infinity to -1 or 1 to infinity. Cosine and sine, their range is the middle. Secant and cosecant, their range is the ends, everything except that middle. Now here is the beauty of this. When you are graphing secant, you don't actually graph secant, you graph cosine. You graph cosine. So this is my parent secant function, so we are going to put in our parent cosine function. Cosine at 0 radians, cosine is at peak. That's my 1. And then it cycles through, right? So if I were to graph the parent cosine function, this is what I would have. Notice that my graph for my secant function builds off of the peaks and the troughs of my cosine function. And wherever I have a 0 for my cosine function, that turned into a vertical asymptote for my secant function. Because at those odd values of pi half, where cosine was 0, that's where secant is undefined. So that gives me a vertical asymptote. Let me hit my autofocus button, guys. That'll come back in just a second. Now we've got our other special angle values. They're giving us the pi fourths and the full values of pi. Pi fourth, my secant value is square root 2. Negative pi fourth and positive pi fourth is positive square root 2. 3 pi fourths, it's negative square root 2. At 0, secant is 1. Pi secant is -1 because that's my cosine function value at those values. What is important for you to know is that Secant, super easy. You graph cosine. You already know how to graph cosine. Anywhere you have a peak, you have a parabola going up. Anywhere you have a trough, you have a parabola going down. Anywhere you had center, that has become a vertical asymptote. Now those vertical asymptotes need to show up in your graph. Don't forget to draw them in. Okay, for secant, discontinuous at values of x at those k pi halves where k is odd. There are no x-intercepts. The period is still 2 pi. One full cycle from 0 to 2 pi would look like this. Or if we scooched it over, there's one full cycle. So one cycle of secant or cosecant is going to be one up, one down parabola. The graph has no amplitude. You still have a value of a, but that value of a gives you your minimum and your maximum values for your parabolas. But the function doesn't have an amplitude because these ends of the parabolas go up to infinity. These ends of these other parabolas that are going down go down to negative infinity. Because there's no true maximum or minimum values, we'd say that the graph of secant does not have an amplitude. It does still use that value of a. The graph is symmetric with respect to the y-axis. Secant, just like cosine, is an even function. So secant of negative x is the same thing as the original function value secant of x. Remember that secant is the reciprocal of cosine. Those are our two even functions. Okay, cosecant, my reciprocal of sine, works exactly the same way. You're not really graphing cosecant as much as you are graphing sine and then turning it into cosecant, because cosecant is the reciprocal of the sine function. Cosecant is undefined where sine x is 0. Well, where is sine x 0? Sine is 0 at the full values of pi. So my domain for cosecant, all values of x such that x is not equal to n pi, where n is any integer, so my full values of pi. Range, still those ends, because we have those parabolas. Think about your sine function. Sine starts at center, travels up to peak, center, trough. I can extend that sine curve in both directions. Where I have peaks or troughs, I've got my parabolas. Wherever I had x-intercepts or center points, those turned into vertical asymptotes. So we are undefined. We have vertical asymptotes at those full values of pi. And that's really what's important there. Okay, cosecant. Discontinuous at the values of x in the form in pi, those full values of pi. No x-intercepts. Period is 2 pi, just like its reciprocal function sine. No amplitude, because there's no maximum and minimum values for the graphed function. It goes up forever, it goes down forever. We just leave out that center that was the sine function it built off of. Just like the sine function, it is the reciprocal of, it is odd, symmetric with respect to the origin. So cosecant of negative x is the opposite of cosecant x. Now this even odd business, this is going to be important later on, so you need to kind of make note of that in your head. Cosine and its reciprocal secant were our only even functions. Cosecant, sine, tangent, and cotangent are all odd functions. We've got guidelines here for those of you who like everything in a nice orderly spot. Here you go. To graph secant and cosecant, you graph the reciprocal function. Right here. You don't really graph cosecant and secant to start. You graph sine or cosine. I don't know why that ended up like that. I apologize. Then you sketch the vertical asymptotes. Don't leave off your asymptotes. They're part of your graph. They come in the form x equals k, where k is an x-intercept. That value of center on your sine or cosine graph, that gives you your vertical asymptote. Then you're going to draw those U-shaped branches between the adjacent vertical asymptotes. If you're at a peak, they go up. If you're at a trough, they go down. And that's it. Like I said, you already know how to do these two because you already did them when you did sine and cosine. Let's do a couple of examples. And by couple, I mean 3. And then we're gonna read some graphs. All right, y equals 3 secant of 2x. This is our first example. We do not start by graphing y equals 3 secant 2x. We start by graphing y equals 3 cosine 2x because that's my reciprocal function. Well, what do I know here? I know that I've got this 3 and I've got this 2. 3 is a value for a. That is the amplitude of my cosine function. B is 2, which changes the period. 2 pi over b gives me a period of pi. I don't have a change in center. I don't have a phase shift. That's all I got. So let's go ahead and graph a couple of periods. We're graphing cosine. We're going to go from 0 to positive pi, and back over here we're going to go 0 to negative pi. Each of those cycles gets 4 equal intervals. That's going to be pi half, pi fourth, 3 pi fourths, and then the same thing in a negative direction. Amplitude is 3. Okay, now I'm going to graph my cosine function as a dotted line. So because that is my structure, that's what I'm building off of to get my secant function. Cosine, positive cosine starts at peak. So I've got peak, center, trough, center, peak, and then back the other way as well. So when I sketch my cosine curve, it looks like this. But this was not my goal. This was my building block. All right, now my function that I was asked for. Start with your vertical asymptotes. Anywhere you have an x-intercept, that is a vertical asymptote. That has to show up on your graph, or it's not a complete graph. Sketch in your vertical asymptotes. They also help us confine our little parabola branches. Make sure that we know we've got those confined to the right areas. When I graph secant, I start with cosine, I draw in my vertical asymptotes, and then wherever I have a peak, I go up. Wherever I have a trough, I go down. I'm confined by those vertical asymptotes. So the actual graph of secant, those vertical asymptotes, and these little parabolas. The range here of my secant function is from -infinity to -3, or 3 to infinity. I left out that middle bit where cosine was graphed. All right, excellent. Now we're going to look at some of the other transformations that we have practiced doing by this point. You should have practiced in my math lab, as well as done the guided notes, any written assignments that were assigned. Okay, 1/2 cosecant x plus pi fourth. Not going to start by graphing cosecant. Where am I going to start? Well, the reciprocal function of cosecant is sine. So I'm going to start with the graph of 1/2 sine x plus pi fourth. Let's see what I have over here to graph. 1/2, this is a value for A. A equals 1/2. That's going to change my amplitude. I don't have a value added on at the beginning or end for C. So my graph, my amplitude for my sine function is just 1/2. So I'm going to go ahead and set that up so that I've got a positive 1/2 and a negative 1/2 on my graph over here. B is just 1. So my period is a nice 2 pi. It's not needing to be adjusted for anything. I do have a phase shift though. This is a D value, a phase shift value. I don't need to factor out a value for B, so my phase shift is actually pi fourth, but is it positive or is it negative? Well, that is a negative pi fourth, which means my phase shift is back to the left. Before we start putting down our x-axis, let's think about our interval size and our 5 points. So our interval size is going to be that interval 2 pi divided by 4. And I'm going to leave it just like that. I'm not going to simplify it because my first point on my period is going to be at negative pi fourth. I need to add 2 pi fourths to that. My denominator is the same. Negative 1 plus 2 gets me to positive 1. Ooh, I don't have a value on the y-axis. I don't have a value at 0 radians. Plus 2 is 3 pi fourths. Plus 2 is 5 pi fourths. And, oh, no, one more. 1, 2, 3, 4, 5 points. That's one cycle. So let's just do one cycle for this. Negative pi fourth, positive pi fourth, and then I made that a really big interval, so I need to keep making them big intervals. 3 pi fourths, 5 pi fourths, 7 pi fourths. There we go. Okay. Because, you know, every interval size should be the same, the distance between each 2 points that I've marked. I made this really wide, so I tried to make these the same width. All right, let's do it as far as this positive sine function, amplitude of 1/2. Here we go. So sine starts at center. So this is not center. That is not my starting point. My starting point's over here because I have a phase shift. There's my starting point, center. Peak is at 1/2. Center. Trough is at negative 1/2. Center. Center, peak, center, trough, center. 1, 2, 3, 4. What did I do wrong? Center, peak, center, trough. I did what I told you guys not to do, didn't I? I put a point on my y-axis. Let me fix this. Okay. All right. So there's my 1/2. Okay, that's why I tell you to watch these things, because these are things that I know I make mistakes at. I've very carefully made sure I had my 5 points, so I knew I had not done something correctly because I didn't end up back at center. Let's try again. Center, peak is over here. Center, trough, and then back to center. That's my sine function that I'm going to dot in because it's not the graph I'm looking for. It's the graph that structures the graph I'm looking for. One cycle. There we have it. Now, vertical asymptotes are a part of my cosecant function graph. Anywhere I have center, I have a vertical asymptote. Anywhere I have center, I have a vertical asymptote. So I have 3 consecutive vertical asymptotes there. The graph of cosecant, series of parabolas, one cycle is one up, one down. So I start at a peak and I go up. I start at a trough and I go down. That is one period, one cycle, confined by my vertical asymptotes. All right, excellent. Let's do one more together. And then we will read those graphs and write equations for those graphs. All right, I encourage you to pause the video and tackle this one yourself before you come back to see what we did together. All right, so cosecant reciprocal is sine. That's what I'm going to graph. I've got my amplitude, my period. Center is not moved, so the range of the function is from -3/2 to +3/2. I can go ahead and set that up. There's my 3/2. There's my -3/2. My first point is going to be at that phase shift, pi/2 to the right. So there's my first point, pi/2. My interval size is also pi/2. Okay, so that's easy enough. So 1 pi/2, 2 pi/2 is pi, 3 pi/2, 4 pi/2 is 2 pi. That's 1, 2, 3, 4. So we need to go to 5 pi/2. There is one cycle. 1, 2, 3, 4, 5. It's the correct width. It's 2 pi wide. And I've got my 5 major points with my 4 intervals in between. I'm going to put in a dotted curve for my sine function, positive sine. Sine starts at center. Center is over here at pi/2. Peak is at 3/2. Center. Trough is at -3/2. Center. And I'm going to curve in that sine curve. That is not the graph I'm looking for. It's my building block. Centers become vertical asymptotes for my cosecant function. That is part of the graph that I'm looking for. I need to have 3 consecutive vertical asymptotes to give me one full cycle of cosecant. When I do my cosecant graph, I've got a parabola up from this peak, and I've got a parabola down from this trough. There's one cycle. Excellent. Okay, so let's wrap up here finding equations for these graphs. Remember, you can always do more than one, but we're going to go with the most basic form of the function. I've got one cycle for each of these because I have one complete up and one complete down. One complete up, one complete down. I'm going to look at, let me get a different color that'll show up. I'm going to look to see what this would look like if I dotted in the function I built it off of. And I see that to get this one complete cycle, I'm going from -2 pi to +2 pi. So my period is 4 pi. That's important. It's spread out. I see that center at 0, center is at the peak. So we're going to assume that this that I sketched in is cosine because the center is at peak if I don't want to throw in a phase shift, and we're going to keep it simple, so I'm not going to throw in a phase shift. My peak is at 1, so A is just 1. The reciprocal of cosine is secant. So y equals secant. A we said is just 1 because that my peak and my trough are at 1 and -1. But I have some value of B that is going to adjust my period so that my period is 4 pi instead of 2 pi. What do I do to B so that my period is 4 pi instead of 2 pi? Well, B is going to be 1/2. If you haven't figured that out so that you can reason through it in your head yet, set it up like this and do your cross products and solve for B. Okay, let's look at the next one. Let's look at this one over here. So if let's see, this looks like I'm at 0 and at -2, so center between them is going to be at -1. So I've got a center at -1. C is -1. Center is also on the y-axis, which means that's a sine function. So I'm looking at y equals cosecant, because that's my reciprocal of sine. I'm going to need more space. Let's do y equals -1 plus maybe something cosecant something x. I got to think about A and B. From center, I'm going up 1 and down 1, so I don't need a value here other than 1. I don't have an A. What about my period? To do a full cycle here, I'm going from -pi to +pi, which is 2 pi. My period is 2 pi, which is standard, so I don't need another value there. So my function is just -1 plus cosecant x. My value for A is 1, my value for B is 1. That would be a 1, that would be a 1. I don't need those ones there. The only thing I need to show is that I have moved it down 1 unit with a vertical translation.